I've been using Haskell for quite a few years now, and throughout all these years, there's been one Haskell feature that has been almost universally disliked. In fact, for many years, I felt like I'm the only one who's not complaining about Haskell records, and people were arguing that that is because I don't use them. And so I don't know. I certainly started using them more over the years, and I've also suffered from them a little bit. And in this episode, we're going to look a little bit at what are the main complaints that people have with the original Haskell record system, but also how is the situation actually looking right now? Because there are quite a few changes that have made it into the compiler, and some of them are actually pretty good. And there are others which are still in the works. And yeah, because there have been so many proposals over the years, it can actually be a little bit confusing to know what one should do. So I'm going to give my recommendations on how to currently use Haskell records.
Yeah, welcome to the Haskell Unfolder, a YouTube series where we discuss all things Haskell. As always, the show is live streamed. We invite you to submit questions or comments in the chat, and we will try to show them on screen and discuss them.
Yes, okay. So what I have here is a sample Haskell module which defines a few data type using Haskell record syntax. And I'm just going to recap sort of the basic points of the syntax, right? So you can define a data type with a constructor, and then you can use these curly braces and commas, and you can give a list of field names and their types. So far, so good. Doesn't look particularly bad, actually. I think it's quite nice. So we have a player type here, which has a couple of fields, and then I have a point type, which has an X and a Y field. I have an item type, which has a weight, and compiler type, which has a version. And then you can define sample values, like I've done down here. So you have a sample player, so 2 sample items, and 1 sample compiler. And actually, all these record types, that is one of the peculiarities, but one which I don't think is particularly bad. I actually quite like it. All the record types, they can also be used with positional arguments still. So as you can see here, where I create a point where I just pass the 2 arguments positionally rather than by name. But if you use the record syntax, you can also flip the order of the arguments around if you like, and that still works, right? So then how do you use them? Well, I mean, so classically, in order to access a particular field, you simply use the field name as an accessor function. So if I want to know the name of me, I can just apply name as if it is a function, and it evaluates to Andres. And if I want to, for example, know the x coordinate of the position of me, I basically just chain the function applications, right? And then I get 42 out. And there is other syntax available for records as well. There is actually update syntax. So if I, for example, wanted to like take me, but then to the items, add a new item. So currently I'm carrying around a book, but if I also want to carry around a fixed point combinator, I can take that fixed point combinator and cons it to the previous items that I've had, and that will create a new player, which now as items has both the item of weight 0, which is the fixed point combinator, and the item of weight 10. So this is all okay, I would say. But there are, I think, 2 main problems that people have been complaining about, and we're going to kind of discuss them a little bit in order. So the first primary problem is one of namespace management and namespace pollution, which we'll discuss first. And then the second problem is one that record updates become really, really weird or difficult or tedious to write. And so let's look at the name problem, which I've carefully evaded. But in fact, I mean, like, for example, you can argue that items really should have a name, and perhaps the compiler should have a name, right? So what if we want to add a name field to the item type? And simply say this should also have a name and a name field to the compiler type. And you can already see that at that point we're getting an error message where the compiler complains, or GHC in this case complains, not this compiler here, about multiple declarations.
Compiler you're talking about.
About multiple declarations of name, right? And right, I mean, so there is a reason for this, because this accessor function, right, that we've previously been using, it has to have a type, right? And if we apply name to me, and previously it was relatively clear that the type of name is person to text, but now if name suddenly is a field in multiple types, multiple record types, it's not so clear what type do you give it, right? And it's not distinguishable from other functions. So how do you know, right? And so this is a big problem. And in practice, the classic way of solving this problem was to basically prefix every record field with basically with a type, or with a abbreviated form of its type. So you would write player name, player compiler, player pos, player items, player strength, point X, point Y, item name, item weight, compiler name, compiler version. Right?
I mean, to be fair, I still do that today.
It's yeah, you still see that around very often, and I mean it's a habit trained over many years,
yes,
and
right.
It's actually difficult to get rid of, but it's not particularly nice, I think,
I agree.
to have to do that, right?
Yeah.
It's quite lengthy. So what can you do to fix this? You can enable a language extension which exists for quite some time, which is called DuplicateRecordFields, and you can and should. Right. I mean, this is one which I think is a recommendation, but it's not a solution on its own. What this will do is, it will change the error messages correctly. I mean, it will the errors for the name are gone. It will now correctly complain that because I've declared these to be strict fields, that my books and items, my items and compilers don't have names. So I mean, this is an independent thing. This is not a shortcoming of my favorite Haskell book. I'm not going to say what it is in this episode.
It's going to be very controversial, very quick.
And let's call this one just Y. And as a compiler, I mean, I'm just going to use GHC. Also,
you mean name there, not compiler.
Yeah, the version number indicates that it's probably GHC and not microHS. So that problem is fixed. But I can now, I mean, I can still do this one, like I can do the expos me, that one, if I refresh the evaluation works, right? But if I try to apply name to me, I'm now still the HLS is sort of copy pasting the output into the wrong position from time to time, but I'm getting an ambiguity error now when I'm trying to use the selector function. So
there's a question that I don't know if you want to talk about it now, but I could
perhaps let's at least see it.
Because you asked about the type of name. So this person asked, why not treat name in this case as a function of a class, and then make both custom data types instances of it? Like that would be an answer to your question, like what type do we give name? Right?
Yeah. I mean that is a valid proposal, and I think it's actually not all that much different from what we will end up with. It is just something that you want automated to some extent, right? I mean, if you really have to start defining your own type classes, has name, has whatever, for every combination of record types you are defining, then you have to write quite a bit of stuff, right? But yes, I think like doing something like a constraint or a class is sort of the obvious Haskell solution and the one that I agree with, but you want some automation behind it, right? And you cannot just assume that any normal function is a record selector. That's why it's relatively, I mean, right? But you might want to say, I want to select name from anything that has a name field, but you somehow need a syntactic distinction, right? And
but I guess we'll see more about that a little bit later.
Yeah, I mean, we're going to see this basically in a moment, right? Basically, I think there is one intermediate step I still want to make is basically saying that, okay, so this is still not really usable. You can declare these types, but you cannot use these ambiguous accessors. Now, you could
say,
I
mean, I've lost, just in case people have lost. So we said that when we enable this extension, we can have records with the same name, and we can define records of those. But when we try to access them, we have we're in trouble.
Yeah. At least if you do something which is ambiguous, right? I mean, if you do something which is non-ambiguous, if I do strength of me, then that should actually work, right? But,
of course.
Now, you could say, okay, well, that's fine. At least some accessors still work. But I would actually argue, because we are going to use a new way of doing these accessors, I would recommend as a second extension to actually enable no field selectors, which disables all the accessors, the classic accessors.
So now we can't access anything anymore.
Now even strength me does no longer work. It just says variable not in scope. So we've actually made things worse to some extent, if you look at it from the aspect of usability, but we also made it better because it now means just declaring a record does not pollute the normal namespace anymore, right? We don't have to worry about it, but we need some other way of accessing record fields. Now, pattern matching, of course, still works, but that is not really satisfactory. There are some other extensions which I'm not going to highlight very much, like there are named field puns and stuff like that, which sometimes can be quite useful. If you're only working with a single record, you can do pattern matching and then name the fields that you want to work with. Ezko actually told me that he's using it all the time, and that's very nice if you're basically having a single record in scope. It's a very convenient way to access some of its fields. But if you have sort of multiple records which have clashing names, perhaps again, or even multiple records of the same type, then it's not really a scalable solution. So there is still something else needed. So basically, the solution to that, which I think is now mostly accepted, is OverloadedRecordDot. And this finally, in a way, brings the syntax that is established in most other languages to record selection in Haskell, namely using a dot. Perhaps I should inject very briefly why this wasn't used in the first place. I mean, you can still argue about trade-offs and so on and so forth, but the point is, the dot is already used in Haskell for quite a few things, even before you start using OverloadedRecordDot, right? So there are qualified names, right, which you write using a dot, module name dot name, in order to refer to a name coming from a different module. And there is function composition, right, which is also written using a dot. And classically, for a dot, it was already always a little bit strange, but classically, Haskell allows you to write operators with spaces, but you can also omit the spaces, and it means the same thing, right? Now we're going to see that if you write f dot g, right, then it means the composition of f and g, but if you write f dot g without spaces, then it means try to select the field G from the record F, right? And this sort of white space sensitive syntax is becoming more commonplace in Haskell, I think. In even because of the qualified names, it was kind of existing even before, but it's introduced in more and more places, right? There are issues with template Haskell splices and the $application operator as well, and stuff like that. So there are a couple of situations now where, in general, I think it is good style to always try to put spaces around operators if operators are what you want to use. Yeah. So that's my general recommendation. Okay, so with OverloadedRecordDot enabled, which I think I did, yeah. So I can now use dot syntax in order to access the name of me, right? And I can also access other fields, or I can access the compiler that I'm using, or I can do a nested access of the compiler's name, and all these work as expected, right? Now, Haskell is a sort of a functional language, and sometimes you still want to use a record access as a function. Say we have a list of, let's say we want to write a function that takes a list of players and just gets all their positions, right? So, okay, right? I mean, how can we do this? We get the players, we can map, it's a simple map, a function over the players. One way to do it is we can say we want to take a player and then we want to select the position, point, I think it's called. And, what is this? Because I imported data.text. Let's just only import the text type. Yeah, I can do this, but actually there is a section syntax for the record dot as well, which I consider very convenient. So you can write this.
I learned something new today.
This is very close to the old style accessors, right? The only difference is you have to enclose and parentheses and add a dot. And so with this in mind, converting a code base from the old style into OverloadedRecordDot is relatively straightforward. Like the real, like sort of the main applications you probably want to write like this, right? But in situations where you don't have sort of an obvious thing to apply it to, like where it previously was just like used in sort of eta reduced form, just as a function that was passed on, you can use this the sectioning syntax. And in a way, you can even nest this, right? So you could map compiler.name to something, then you would get a list of text out. Okay.
So you I might be going ahead, but I'm just wondering now, because you talked earlier about that we don't know what the type of name is. So if you go back to map.name and you leave out the type of example, what happens?
Sorry, and?
So go back to map.name rather than compiler.name.
Yeah.
And now omit the type of example.
Yeah, that would have been the next thing that I would have done anyway.
Okay.
So we are getting an ugly inferred type here because it comes from some weird module. But let me actually just import the right module. Import jhc.records. Records. So the type we get inferred is one which has a class constraint, as had been suggested. So basically, this is the way that the record dot syntax works. And whenever you use a dot access, it generates or introduces one of these constraints. And the constraint is a has field and then a type level string, right? Also called a symbol. And then the type of the record, which is A here, and the type of the field. Right? And these constraints are primarily automatically solved by the compiler, right? If you make record declarations, then the obvious constraints are automatically solved. But perhaps somewhat interestingly, you can actually define your own instances as well. And this is allowed. I mean, I'm not personally sure whether I think it's a good idea, but it's a funny thing. And I can certainly imagine that there are some situations in which it may be useful, right? So you can do something like, let's say we want to give a new a virtual field to the player type. I can say instance has field, let's say capacity, player, and that should be an int where, and then I say something like has field, or no, I think get field is what the method is called. So get field is then a function from player to int, so I'm getting the actual player. And now I can, for example, do what do I want to do? I take the items that the player has using dot syntax again. Of the items, I take their weight, and then I sum those weights, and then I subtract that number from the strength of the player. Right. So basically,
I have no idea what any of this means, but I guess it doesn't really matter.
No, this is just basically the idea is how much can I still carry? If the strength specifies a number that indicates how much stuff I can carry around, and every item has a weight, so I subtract all the weights of all the items, and then and that is what I can still carry. And and then I can say something like me.capacity, and I can use the dot syntax for that. It just works, right? You can do even weirder stuff, which I would be even more careful with. I mean, this I think is harmless. I mean, so and you can use that to create some amount of interface stability, perhaps, right? I mean, so to say, perhaps you change a record field into something which is actually computed, but you can still allow access as if it was a record field or something like that. So I think it's a good idea. But you can even do something like, oh well, wouldn't it be nice if for a list of things we could just use the attributes of the item of the contained thing? So you can say something like has field for an arbitrary name of list of A of some type B. If we have has field of name of A and B, and then you can say get field of P. Well, the idea is just we want to take that same field, but now we have to use we have to pass it like a type argument, because we have to call get field on each of the items of the list, right? So this is a list.
Why can't you map?
But what do I want to map? I want to map.
I see.
Right, and actually, I also need undecidable instances. So
it's for any. This is not the name. This is not the field name. This is.
Yeah, and actually, I want
some arbitrary field.
List of B here as well. And then, so what do I want? I want to get the same field, right? But now, if I just write get field again, then GAC will complain that it doesn't have enough contextual information to actually determine which field we want to get. And we need to specify this type level string here, which is the name, and we need to pass that explicitly as a type.
Perhaps slightly confusing. This you called it name, but it's not the name that we've been talking about up to now in this episode. It's some field.
Yeah.
F field, whatever.
F field. Let's call it field.
Yeah.
Okay. Yeah. That's a good point. And now I could rewrite, I wouldn't have to do the map weight here.
No.
I could write P items weight, and it would still work.
Okay.
So I would be really careful to equip existing types.
I feel like this is where I should show
with new virtual fields, but it is still interesting that you can do it in principle, and you could wrap the list type in a new type of your own, and then I think it's reasonably harmless to do that. Sorry, what was the comment?
This was a comment.
I think. Okay, all right. I think this pretty much settles the original problem, right? I mean, so I think
there's an interesting question now, which is this an orphan instance?
For the list, it would be an orphan instance, I think.
You have warnings disabled?
Let me just double check.
Okay. I see. Anders doesn't believe in warnings.
No, I actually do, but I sometimes, if I create a new file, I'm I don't. It's not an automatism for me somehow to write W all into the Cabal file, so I sometimes forget it. Let's actually keep it in. Yeah. So yeah, I mean, for the list, it is an orphan instance, right? But for the player here, this one is not, because the player is defined in this module. And if I would follow my own recommendation to at least wrap the list in a new type and then define this kind of instance for the new type, then I would also not have an orphan instance. It's a good point. Yeah. So I think this is even more discouraged in a way. So let's keep the warning there as a reminder for us that it's there. So let's briefly talk about the other problem, right? I mean, so this was all about accessing things, and I think this is a good solution for accessing things, and this really nice and convenient and everything. But there is another problem, right? And that is coming if, for example, if I want to write a function moveRight that takes a player and gives me another player, and it should just increase the x coordinate of the position of the player by 1. How would I write that, right? So I take the player and I want to update the player with a new position, okay? And the position should be a modification of the old position of the player, which is position of p, or well, now it's p.pos, right? And now we have to write a point-to-point. And so basically, well, actually what we want is we want this position, and then we want to update the coordinate x with a new value, right? And then what do we want to put here? Well, the p.position.x, right? And now, actually, record.syntax is already making this nicer, right? If you imagine you would have had to write this like using normal selector functions, it looks even more confusing, I think. But nevertheless, it isn't particularly nice, right? What we would like to write,
I guess you meant a +1 in there or something? Not that really matters,
but +1, yeah. What we would like to write is p, where we can just say pos.x is p.pos.x +1. Right? Mm-hmm.
That would be fine.
And this is proposed and partially implemented. So there is a language extension called OverloadedRecordUpdate, which you can enable right now, but it's only partially implemented. And I would say the most important part of it is not implemented. So what it kind of does is it does translate all updates in this syntax into calls to a set field function, but it doesn't actually generate the basically solve the constraints, right? Or
doesn't make the instances, you mean?
It doesn't. I mean, it doesn't really create instances in the get field case either. It just solves the constraints.
Yeah, but you can think of it as
yeah, you can think of it as defining the instances, and that doesn't really happen for set fields. So basically, you have to do two things. First of all, you have to swap out yourself the definition of the Haskell class for one that defines set field. So this is actually something which is still simple enough to do, because there is a package on Hackage which is called record Haskell, which defines a ghc.records compat module, which basically explains how it would then have to look. So you have a Haskell class as before, and the Haskell method now is different. It actually takes an old record value and it gives you both the accessed attribute of type A and an update function where you can feed in a new A and then you get a new record out. Mm-hmm. But yeah, it doesn't solve the constraint. So you have to basically define all the instances of Haskell yourself. And I think apart from in a few special cases, this is completely infeasible. It's certainly infeasible if you have your own named records and you have lots of them, and you would have to define everything like that on your own. There are some situations where you, like if you define your own sort of anonymous records library, like ETSCO has, I think large anon, right? Then you have like many records that are all belonging to a single type, and you can perhaps use this
it supports it,
right?
Yeah.
but in the normal scenario, not, right? And now I think there are two. Well, I mean, the eventual plan is that this is going to become fully implemented, but we don't exactly know when, right? I mean, I have to ask my colleagues. Like my colleague Adam is in principle working on this, but yeah, so I should be patient, I guess. But I'm very much hoping that it will eventually happen. I should probably do it myself rather than complain, but yeah, I mean,
there is a question here that I don't know if you want to address now, but
let's just
kind
have
of
it
on topic. Yeah. So once updates work, I don't have to understand lenses anymore. Here's the question.
I tried to get into this. I got the impression it's just a genius hack to get back normal record syntax. So, well, yes and no. I think once updates work, you may just pretend that you don't need to understand lenses, but certainly if you understand the Hasfield class as defined here, you do understand lenses. because that's exactly what this Hasfield method is.
But it's nonetheless fair, right? I mean, you might not even see this. Like you might just write p.point equals something and then never see this. So
yeah, and I think it's valid. I mean, I think it is easier, and I am very much in favor of eventually exposing that. And I think it will be good to have it because it's, I think, a gentler curve, right? You can start using it. It has a relatively obvious meaning, and then if you look into the deeper details, you will still sort of be automatically exposed to something like lenses, and you'll start understanding it. But you don't have to understand them up front, so to speak. So yeah, I think it's a fair point. But basically the answer for now indeed is, I would say, use lenses explicitly if you want to do updates. So there is also, I should say, there is this record.preprocessor, preprocessor, which in a way, like I think it was written by Neil Mitchell. Neil Mitchell was one of the original proponents of this whole overloaded record.dot syntax. He made a strong case for it, and he wrote this preprocessor originally in order to show this all can be done in times when GHC supported none of this, right? And it still exists, but I think this is the problem with preprocessors, and I think there's also a plugin. At least as a plugin, it won't work with most recent versions of GHC. As a preprocessor, it actually might, because you can just compile it. But I didn't try it out. But I always, I feel like preprocessing is a little bit fragile. I would rather have an in-language solution. So my recommendation for updates...
before you go to the lenses, there's another question about this.
Complicated updates is to use optics. Yeah, okay.
Yeah, sorry.
No, it's fine. Show.
By the way, I have used record.dot preprocessor, and like it certainly has its benefits. But just there's a question about.
I'm not trying to dismiss.
No, I know.
I mean, it's a valid approach. It's just not really for me personally. But
and it's difficult to keep it up to date. I mean, that's absolutely true. So there was a question about when you showed us the new Hasfield class.
Mm-hmm. Sorry. Okay, yeah. No, sorry, this one. Yeah.
This one, yeah, exactly. And the question was, with this proposal, can we write stuff like this? Like, can we do updates? Do we get this kind of thing?
I think there are, as with all the record proposals, there are hundreds and hundreds of comments, and I'm sure some of these things have probably been discussed, but as far as I'm aware, that is not the currently accepted proposal to allow.
But you don't, I mean, in terms of maybe not for syntax, but once you have this, you could easily write such a function. Right, all you need is if you have Hasfield, you basically have a lens, so you could definitely write this.
Yes, but yes and no, because I mean, if you show again,
yeah.
I mean, so the p.post.x is in this syntax is just an access, right? So this will already be resolved to an access and not to
Oh,
the
I
lens.
see, you won't get it.
Right. So
It will be-
tactically, you won't be able to just
Right.
write that, and you would need a way to access the actual lens, right?
Yeah, I see.
Rather than
Yeah,
just.
so it's possible, but definitely not convenient.
So possible with extra work to the proposal.
Yes,
And as far
yeah.
as I know, this is currently not part of the overloaded record update proposal. Okay, yeah. So my recommendation for updates is to use optics effectively. I mean, so I'm always a little bit hesitant because optics is a library that I have been myself been involved in creating, even though all the hard work has been done by others. No, by basically by all the others that are on the author list except me. So like Adam, Andre, and Oleg. So they have all done work. I have only been complaining. So
As you do.
yeah, and of course you can, in principle, you could use other lens libraries. The reason I'm primarily proposing optics specifically is that I think it is very straightforward. You don't have to do very much in order to actually get it get to use it in a setting like this. So what do we have to do? We have to import optics. And okay, so it's currently redundant. And you need one more thing. You need to derive generic. And for that, I need to import generic GHC generics for each of the record types. But you don't need to use template Haskell or anything. And then you can make use of another feature of GHC, which also exists and is also a language extension, which is called overloaded labels, which is a bit similar to OverloadedRecordDot in the sense that every time you write a term such as hash and then any name, right, and you ask for the type of this, it now actually gets a class constraint that says, well, if there is an instance of the isLabel class for this type level string of type A, then I can pretend that this thing is of type A. And what...
Not just pretend, it really is. Not just pretend, it really is.
Yeah. And so what the generics stuff does and the optics library defines is that we can basically use all the field names automatically of all the types as lenses. So I can use name at the type lens. So let me just to emphasize this, or name lens, just to emphasize that I can do this, right? This is just a type specialization. At the type lens of, for example, player to to text, right? And this type checks. And I'm not going to explain in this episode. This deserves its own episode, really, sort of like the full theory behind lenses and what they are. But the point is, we can use them like this, and then you can do an update according to what we did with player to player, similar to what we did before. You can basically write over is sort of the update function where we want to modify something. And now you have to give a lens, which basically says where we want to update. And so within the player, we want to update the position. And then you can compose lenses in optics using %, not dot. That's one of the differences with Edward's lens library, where you can use the actual function composition here. And then you can use the lens to access the X field, right? And then we can give an int to int function here, which in our case should be +1. And that's, I think, a very convenient way to write updates. And that's what I use. So to summarize, basically, basically the message, what I think it's sort of a transitionary state. It's not very beautiful, but it is still pragmatic in my experience. So do enable duplicate record fields, do enable NoFieldSelectors, do enable OverloadedRecordDot as effectively globally for your entire project. And then use a record dot syntax for record accesses. Use the dot access lenses if you want to still use accessors as like functions that you can pass on, and use optics via these overloaded labels in order to perform updates. That's sort of my summary recommendation. And yeah, I mean, in order to do optics full justice, you can do a lot more with that. You can also define sort of virtual accessors. You can define traversals. You can do matching on constructors. You can do many, many, many more things with that. But even just for this plain simple stuff, you don't have to understand very much. You're only using lenses then in order to do these kinds of updates. That's very straightforward still, and I think it works nicely in practice. And yeah, hopefully at some point in the not too distant future, we'll also have the overloaded record update implemented, but not probably in 2025. But we'll see. That's it, unless there are more questions. I don't know.
So, I mean, for me, this is interesting because I don't use this style, so I should think about using this style. It's interesting. I do have a question actually for myself. Mm-hmm. You showed the type of is label, and it was very general. I just like if this particular string has label as type A, then the whole thing has type A. And now these are interpreted as has fields. So does that mean that if I import optics, overloaded labels are sort of hijacked to always mean an optic?
No, it depends on what you're using them at. So they are used as, I mean, let me, yeah, there's a lot of stuff which is being printed here. Let me see.
Maybe too technical a question.
I can actually, why is it not showing me the actual, what is going on? Oh, this is all coming from the constraint label. So, why? This is a bit weird. But the type this is being used at is a lens, right? I mean, so you can have multiple instances for the same label.
Oh, I see. I can have an is label foo A as well as an is label foo B in scope.
Yeah, so if you look at the is label class, or has label, I think.
Sorry.
Right? Is it? No.
Sorry, not in scope.
Oh yeah, I probably have to import the right module. Where was it coming from? No, is label.
It doesn't tell you. That might just be a bug.
Data comes from.
It's in g.overloaded labels. It says package for Google.
Yeah. Okay. Yeah. Okay. This doesn't have any functional dependencies or anything alike, right? So you can define multiple instances for the same, and you can actually see the instance that the optics library defines right here, which is an instance specifically for the optic type, which is the general type that is underneath, in particular lenses, but also some other kinds of optics. And this doesn't conflict with other uses. It would only conflict if you wanted to give your own label instances for this optic type.
Right, sure. And that's also why you recommend optics rather than lens, because it makes this a bit easier to do, right? This overloaded label.
Exactly. This is the point. Because optic has an actual type, you can define such an instance relatively easily. Whereas the way that the lens library works is all these things are effectively just functions. Right. All the different optics are effectively just functions, which makes it much harder to define instances for these kinds of things that they do not already have. I mean, the benefit is that you can do things with them that you can do with functions. And so, for example, it almost miraculously is the case that function composition is optic composition. So that is really, really cool. And I admit that as well. but it makes other things harder, such as defining these kinds of instances.
So I have one final question from you, from the audience. Haskell Unfolder stream on marathon optics. When?
Yeah, I mean, let's do a 5-hour episode, right? No, I mean, I think we can do it at some point. I mean, in general, we are really not trying to do sort of like to make this sound too much like an advertisement stream for our own library. Sometimes we cannot really contain ourselves and still do it, but probably not a very next episode, but sooner or later it will definitely happen.
But having an episode or two about optics, whether it's optics or lens, but the concepts will definitely
the concepts.
Okay, let's leave it there.
Okay.
So thanks everyone for watching this episode of the Haskell Unfolder. We'll get the technical characters right eventually. It's only been 2 years, right? If you enjoyed it, please like and subscribe, and feel free to leave any comments below. We'll leave the chat open for a few more minutes in case you want to ask any questions there. Otherwise, just put them in the video description below the video description rather. See you guys very soon.
Hopefully with a shorter break this time.
Yes, let's hope so.